We're going to keep talking about maxes and mins, and today we're going to focus on absolute maxes and mins, and then next class period we'll talk about local maxes and mins. So we know from last class that we expect maxes and mins to occur at critical points, so places where the derivative does not exist or is zero. And today we're going to talk about absolute maxes and mins on closed intervals. So what we're going to do in this case is we're going to look at functions that don't continue forever, but are stop at some places. So maybe a function like this. So the extreme value theorem that I have written here says that if I look at a continuous function on a closed interval, so there's two conditions that we're working with here. The function has to be continuous and we're working on a closed interval. And so that would be like this example that I have here. I don't know, maybe this is -2 and this is 4. This is a closed interval because the function attains values at the endpoint. So if these had been open circles, whoops, at either of the endpoints, then this would not be a closed interval. This would be an open interval. So we want a closed interval. So we want our function to be defined all the way to the endpoints. And we want a continuous function. This function's continuous. I can draw it without picking up my pencil. So if we have a continuous function on a closed interval, then the extreme value theorem says that our function has an absolute max and an absolute min somewhere on the interval. And if we think about how this compares to the other things we were doing, like somebody has asked me in class, well, what about kind of something like this? This function does not have an absolute max. It has a local max here, but since the function keeps going off to infinity, there's no absolute max. So the extreme value theorem does not apply to this function on the right, though, because this function is not on a closed interval. So extreme value theorem says if we have a continuous function on a closed interval, then we have to have an absolute max and we have to have an absolute min. Okay, so our question is going to be, okay, well, how do we find those absolute maxes and mins? We know critical numbers are one place to look, but what does this closed interval tell us? So let's look at a few examples. So this one here we have here, we've got our absolute min at this point here. That point's a critical point. It's a place, or a critical number, it's a place where the derivative is 0. Our absolute max is over here. That is an endpoint. Okay, let's draw a few other examples to see what else could happen. So we could draw something like this. So we've got our absolute min down here at a critical number, our absolute max up here, also at a critical number, both places where the derivative is 0. We could have something like this. Well, let's just draw a straight line. We could have something like this. That's a continuous function on a closed interval. My absolute max is up here at an endpoint. My absolute min is also at an endpoint. And let's draw maybe one more example. We can have things that have yeah, let's make this low point to the same. We could have something like this, closed circle down there. These 2 points are both where the absolute min occurs. The y value is the same at both of those. Those are both critical numbers. Our absolute max is up here. This peak is just a local max. Okay, so what we're seeing here is that critical numbers are places that we can look for absolute maxes, but also endpoints. So if we have a closed interval, we also have to check our endpoints. Okay, so let's do one example to see how we apply this, and then we'll do a lot more in class. So, okay, so this problem says find the absolute max and min of this function on the interval -1 to 2. Okay, first thing to ask ourselves is this function continuous? It is, because it's a polynomial. So it's continuous because it's a polynomial. So we know that it must have an absolute max and an absolute min. So we know that our absolute maxes and mins can occur at endpoints or at critical numbers. So we want to start out by finding our critical numbers. So let's find our critical numbers. And to find our critical numbers, we start out by taking a derivative. First thing we always want to try if we don't know what to do. So our derivative here is 3x squared plus 7x plus 2. if we factor this, I think we might have actually done this one in class. This is going to factor as 3x plus 1 and x plus 2. So our critical numbers are -1/3 and -2 from setting each of those pieces equal to 0. We don't have a denominator here, so there's no places that the derivative does not exist. So we only have two critical numbers. And so now we know our critical numbers and our endpoints are places that our absolute maxes and mins could occur. So what we're going to do now is we have to figure out what's our biggest value, what's our smallest value. So we're going to plug values into the original function, not into the derivative. So we're going to plug our endpoints and critical numbers into f. This is the original function. This is not f prime. I did not make a typo. I did not make a mistake there. We're plugging things into the original function to see where we get the biggest and smallest y values. Okay, so I'm going to plug f of -1 in. I'm going to plug in f of 2. And then I'm going to look at my critical numbers. And we only care about critical numbers that live between -1 and 2 because that's the interval we're working with. And I'm going to notice that -2 does not occur on that interval. So I'm only going to keep -3. Okay, you always want to be careful about that. So I'm going to, or -1/3, sorry, not -3. I'm going to plug in f of -1/3 as well. Okay, so now we're plugging these back into the original expression, okay? And when we do that, when I plug -1 into that, I get 1.5 out. You guys should actually do the work, plug it into a calculator. When I plug -1/3 in, I get 0.685. And when I plug in 2, I get 27. So now we look at the y values that we've gotten. This is my biggest y value. So this tells me that my absolute max is 27 and it occurs at x equals 2. Okay, and then my smallest y value is this one. So this tells me my absolute min is 0.685 and it occurs at x equals -1/3. Okay. And in class, we'll look at the graphs and just kind of make sure that it makes sense with the graphs as well.